Welcome back everyone to another video. So today we'll be going through the 2020 Mathematics Standard 2 HSC examination. So let's get right into it. So we should have 2.5 hours to complete this with 10 minutes of reading time for 100 marks. That leaves 90 seconds per mark. Alright, let's begin. Question 1, multiple choice. So, which of the following could represent the graph of y equals minus x squared plus 1? Well, looking at these, we know that this represents a parabola. So A is a straight line, B is an exponential, D is a hyperbola, and C is a parabola as required. All right, moving on. So what is 0.002073 expressed in standard form with two significant figures? Okay, so two significant figures, let's worry about that part first. So the first non-zero number is a 2. And then we always put a decimal after that, and then we'll round up. So it's a 7, so we'll round up that 0 to a 1. Okay, so then we'll get a 2.1. Now we just need to think, how many moves has this decimal place made? So it would need to go back 1, 2, 3 jumps. So then we'll know that it's 2.1 times 10 to the negative 3. And we get D as our answer. Okay, part 3. So, the distance between Bricktown and Koala Creek is 75 kilometers. A person travels from Bricktown to Koala Creek at an average speed of 50 kilometers per hour. So how long did it take the person to complete the journey? Well, how many lots of 50 kilometers are there within 75 kilometers? Well, there's just 1.5. So it would take us 1.5 hours, or 1 hour and 30 minutes. Okay, part 4. So Joan invests $200. She earns interest at 3% per annum, compounded monthly. So what is the future value of Joan's investment after 1.5 years? Okay, so let's use our compound interest formula here. So we get that A equals P outside of 1 plus R over N, all to the N times T. So N is the number of times that it compounds per year, and T is the number of years. So we'll find that the future value at A is going to be equal to, so P is 200, and times by 1 plus R is 0.03. Then we divide that by 12, since it's compounding monthly. It's to the power of NT, so it's going to be to the power of 12, times by T is how many years, so 1.5. Okay, fantastic. So when we put that into our calculator, we'll find that it's going to be option B. Alright, moving on. Question 5. A plant stem is measured to be 16.0 centimeters, correct to one decimal place. So what is the percentage error in this measurement? So to figure out percentage error, first we need the absolute error, and that is found by going 1 unit over from the lowest that we can measure and letting it be equal to 5. So the absolute error here would be 0.05, since the precision of the measurement was to the 0.0 centimeters, so this one, so then we go 1 more, and let that be equal to 5. So we put that absolute error over the value that we've just measured, so 16, and since we want this in percentage, well, we cannot forget to multiply this by 100. And again, substituting all those values, chucking it into your calculator, we find that our answer is A, 0.3125%. Okay, question 6. Suppose that y equals minus 1 minus 2x. When the value of x increases by 5, the value of y decreases by, so we've got 1, 2, 5, or 10. So if you can see it right off the bat, then fantastic. But let's quickly go through and test what this actually will be seen as. So what I'd like to do is I'd like to start off with x equals 0. So initially we'll set x equals 0. Then what will y equal? Y will equal to negative 1 minus 0, so y equals minus 1. And now, if we increase the value of x by 5, so now we let x equal 5, let's see what y becomes. Now y becomes minus 1 minus 2 times 5, so minus 10. Or in other words, minus 11. So what is the value difference between y equal minus 1 and y equals negative 11? Well, it's going to be a decrease of 10, and that's option D. Okay, 7. Which histogram best represents a dataset that is positively skewed? Okay, so when I think positively skewed, I like to think positively skinny. So that means that the positive side, that's going to be the skinniest section. So here we see option A has the skinnier side on the positive end. So B would be negatively skewed, C is approximately symmetrical, and D is approximately uniform. So option A is our solution there. Okay, part 8. So John recently did a class test in each of 3 subjects. The class scores on each test were normally distributed. The table shows the subjects and John's scores, as well as the mean and standard deviation of the class scores on each test. So we have French, Commerce, and Music. So, relative to the rest of the class, which row of the table below shows John's strongest subject and his weakest subject? Okay, so let's go through and let's figure out his z-score for each. So, just a reminder, our z-score formula is equal to x minus mu all over sigma. So, for French, we'll say that his z-score is equal to, well, x minus mu divided by sigma. So, they've set it out quite nicely for us. So, 82 minus 70 leaves us with 12. 12 divided by 8 gives us 1.5. Okay, so that's French. Let's see, Commerce. 80 minus 65, that leaves us with 15. Divided by 5, that equals 3. So he's done very well in Commerce there. Now for Music, 74 minus 50, that's 24. Divided by 12, so Z equals 2. So we can see that his best performing course was Commerce, and his weakest subject was French. So our answer will be option A. Okay, moving on. Question 9. Team A and Team B have entered a chess competition. So Team A and Team B have 3 members each. Each member of Team A must play each member of Team B once. So which of the following network diagrams could represent the chess games to be played? So what we need to consider is how many people does each person verse. So one person on each team will verse all 3 people on the other teams. So option A, let's have a look at that. So this person will verse 2 people. So it is not going to be option A. We have a look at option B, and this person versus 1, 2, 3 people. And we can see that each person in option B will verse 3 different people. So clearly our answer will end up being B. And if we keep looking ahead, C and D just become increasingly more incorrect because they're proposing more games to be played than is actually being played. All right, question 10. A plumber charges a call-out fee of $90 as well as $2 per minute while working. Suppose the plumber works for T hours. Okay, so right off the bat, we've already seen something that they're trying to trick us on. So they've given us $2 per minute, but we're measuring it in hours. So we need to be really careful of that. So which equation expresses the amount the plumber charges in dollars as a function for time T hours? Okay, so we know that there's a $90 call-out fee. So right off the bat, we know that there should just be an initial $90. So it's either going to be B or D. So clearly it's not going to be A or C, because, well, where did that 2 come from? And where did that 120 come from? So neither of those really make sense. So B or D. Now we need to be careful. Is it going to be plus 2t or plus 120t? And so if we're being careful, we will recognize that it's $2 per minute, but t is measuring hours. So how many minutes are in an hour? There's 60. So when we say 60 times by 2, that's 120. So for each hour that this plumber is there, they'll be earning $120. So it's going to be option D. So the call-out fee plus their hourly rate. All right, part 11. An asset is depreciated using the declining balance method with a rate of depreciation of 8% per half year. The asset was bought for $10,000. So what is the salvage value of the asset after 5 years? All right, so our formula for this is very, very similar to the compound interest formula. So it pretty much looks like this. So our salvage price is equal to our initial price times by 1 minus the depreciation rate, and then all to the power of the number of compounding periods. Okay, so P is equal to 10,000. Then we have 1 minus R. What's the rate? It's 0.08. And then to the power of n, how many periods do we have? We have, well, it's 5 years, but there's every half year. That's when we factor the depreciation. So 5 times 2. So we'll have it to the power of 10. Okay, and so when we go through and put that into our calculator, we get an answer of 4,343 and 88 cents. Alright, question 12. So for a set of bivariate data, Pearson's correlation coefficient is -1. So which graph could represent this set of bivariate data? Okay, so a correlation coefficient of -1 essentially means that it's just going to be straight down like that. And so we see that the only option that's somewhat fitting to that sort of correlation is going to be option D. Alright, part 13. When Jake stops drinking alcohol at 10:30 p.m., he has a blood alcohol content of 0.08375. The number of hours required for a person to reach zero blood alcohol content after they stop consuming alcohol is given by the formula of time equals BAC divided by 0.015. At what time on the next day should Jake expect his BAC to be 0.05? Okay, so it's an interesting one here. So what we want to see is we want to see his blood alcohol content decrease from 0.08375 to 0.05. And we want to find out how long will that take. So what we'll do is we'll figure out the difference between those two blood alcohol contents. So 0.08375 minus 0.05. Okay, so that's the difference in blood alcohol content. That's the amount of blood alcohol content that we want him to decrease by. And we know that it takes, 0.015, that will go into that BAC difference for so many hours. And when we put that into our calculator, we get an answer of about 2.25. So it will take 2.25 hours for his blood alcohol content to decrease from 0.08375 to 0.05. Okay, so what we need to do is now we need to look at the time. So 10:30 p.m. plus 2 hours is going to give us 12:30 a.m. But then be careful with the 0.25. Realistically, that's 0.25 of an hour. So it's a quarter of an hour, so 15 minutes. So that will leave our answer at 12:45 a.m. Alright, so question 14. An annuity consists of 10 payments, each equal to $1,000. Each payment is made on the 30th of June each year from 2021 through to 2030 inclusive. The rate of compound interest is 5% per annum. The present value of the annuity is calculated at 30th of June 2020. The future value of the annuity is calculated at 30th of June 2030. Okay, without performing any calculations, which of the following statements is true? So present value less than 10,000, less than future value of the annuity. Well, actually, right off the bat, that is our correct option. So option A is correct, and let's have a quick think about why. So it says the present value of the annuity is calculated at the 30th of June 2020. So we have at most got $1,000 in, whether that's, we have zero money in our account at the moment since that we haven't put any deposits into this annuity fund. So the present value would actually be a zero. The future value, well, we'd have to use an annuity table to figure that one out, but we should know that it will be greater than $10,000 because all up, we will have put in $10,000 and we'll have been making a compound interest rate of 5% per annum profit. So we'll see that option A is our correct answer. All right, question 15. The top of a rectangular table is divided into 8 equal sections as shown. A standard die with faces labeled 1 to 6 is rolled onto the table. The die is equally likely to land in any of the 8 sections of the table. If the die does not land entirely in one section of the table, it is rolled again. So a score is calculated by multiplying the value shown on the top face of the die by the number shown in the section of the table where the die lands. Okay, so what is the probability of getting a score of 6? Alright, let's think about rolling the die. So we can have 1, 2, 3, 4, 5, or 6. So let's think about if I roll it onto the square of 1, what would I need the die to be? It would need to be the 1 with a 6 on the die. Okay, what if I roll the dice onto the 2? Well, then I would need it to be the 2 times by, I would have to roll a 3. Now, if I rolled it onto the square that says 3, it would need to be that 3 times by a 2 on the die. And now if I roll it onto the 4, there's no option that will lead us to get a value of 6. Similarly for 5. So rolling it now onto the square that says 6, we would have our final option of 6 times a 1, which we roll on that die. So we've got 4 different methods by which we can actually roll a value of 6. So now we need to think, well, what is this going to be over? So we've got 4 over something. So what's the total probability going to be out of? It's going to be out of 6 times by 8. So the number of different ways that we can roll the die versus the number of different ways that we can land on the table. And so when we compute that, we get an answer of 1 over 12, leaving us with option B. And there we go. So that concludes the multiple choice section of the 2020 HSC. Now let's get a start on the extended responses. Okay, now on to question 16. So consider the triangle shown below. So part A asks us to find the value of theta, correct it to the nearest degree. Okay, so as this is a right angled triangle, we can just use our SOHCAHTOA. So looking from the perspective of the angle of theta, well, we see that we have the opposite over here, adjacent over here, and our hypotenuse is the side length here. So we know the opposite and we know the adjacent, so we're going to go ahead and use the tan function. So we can say tan of theta is equal to, we know it's opposite over adjacent, so it's equal to 8 over 10, or you can simplify that as just 4 over 5. Okay, solving for theta, we take the inverse tangent of both sides, and we find that theta is equal to tan inverse of 4 over 5. And when we round that to the nearest degree, as the question is asking, we get that theta is equal to 39 degrees. And that's part A. Okay, part B. Find the value of x correct to 1 decimal place. Alright, so the trick here is that they want you to try to use this angle. And if we do that, we will actually be incorrect. And the reason for that is due to rounding errors. So if we end up using some other trig relationship to figure out our side length x, we will be incorrect unless we use the exact value of theta, which we have not used here. So what we should probably do instead, actually, is just use Pythagoras' theorem. So c squared equals a squared plus b squared. So c squared is our hypotenuse length squared, and a and b are going to be the other side length there. So substituting all those values in, we find that x is equal to the square root, already solving for our missing side length, to the square root of 8 squared plus 10 squared. And putting that into our calculator, we get that x is equal to 12.8, and that is correct to 1 decimal place. Okay, and that's question 16. Easy 4 marks. Question 17. Ayla wishes to estimate the number of trees on a square block of land measuring 1,000 meters by 1,000 meters. She counts the number of trees on a 5 by 5 meter section of the block and finds there are 8 trees. So based on this, estimate the number of trees on the entire square block of land. Okay, so what this type of question is going back to our rates and ratios style of questions. So what we can say is that for every 1,000 times 1,000 is 1 million. So a million over, and what was the area we measured? It was 5 times 5, so I'll just write 25. And these are both, of course, being measured in meters squared. So we have the total area over the measured area that we actually counted on. And that's going to be equal to x, the total number of trees on the 1,000 by 1,000 meter plot of land, divided by how many trees did we find on the 25 meter squared? Well, we found 8. And this is just going back to our basic rates and ratios. So now to solve for x, we simply multiply both sides of this equation by 8, and then we end up with 8 million divided by 25. And so we see that x, the total number of trees on this plot of land, is equal to 320,000. So quite a few trees there. All right, question 18. The diagram represents a network with weighted edges. So there's our network diagram here. So we need to draw a minimum spanning tree for this network in the space below and determine its length. So what I'd recommend doing right off the bat is going through and just drawing in all of our different vertices. Since it doesn't matter which paths we take, we will still need to draw in all of our vertices. And it will just save us a little bit of time in terms of the neatness of everything when we try to draw it out properly in a moment. Okay, so there's all of our vertices clearly labeled. So let's go, we can either use Prim's or Kruskal's algorithm. As I've mentioned in other videos, there are a few different other algorithms you can use, but I think I'm going to go ahead and use Kruskal's. So just going through this network and selecting the lowest weighted edges first. So clearly the lowest weighted edge is GH, and that has a value of 1. And we see there's no other 1s in our network here. So next up is all of the 2s. So I'm going to go ahead and pick, let's say, FH. So that has a weighting of 2. And now note, we won't join F to G because that would create a cycle and that would kind of destroy the definition for a minimum spanning tree. All right, so continuing on, any other 2s? There's plenty, in fact. So let's say C to F, that's a 2. What about D to F? That is also a 2. So we'll go ahead and draw those in. All right, E to D, that's another 2. And now we start looking and, well, we kind of see that we need to start joining up the B to either C or E. And we also have A to B, which is the obvious route that must happen to join A. And now we have a bit of freedom of choice to connect B to either C or E, and it doesn't matter. They're both the exact same weighting. So I'm going to go ahead and join B to E. And now we see that every single vertex is connected by some path here. So to find the minimum length of the spanning tree, well, that's just adding up all of the different weights now. So 2 plus 3 is 5, plus 2 is 7, plus 2 is 9, plus 2 is 11, plus 2, 13, plus 1, 14. And that's our answer there, 3 marks. Okay, part B. The network is revised by adding another vertex, K. So now edges AK and CK have weights of 12 and 10 respectively, as shown. So we've just introduced this new vertex over here. So now it asks us, what is the length of the minimum spanning tree for this revised network? Okay, so we need to connect K to either C or A. So which is going to be the better option? Clearly it's going to be to connect it from K to C, as that has a weight of 10 rather than 12. So the length of the minimum spanning tree now is just going to be 14 from before, plus the 10 from KC. So a weight of 24 is the new length of this minimum spanning tree. All right, on to question 19. So this one's a bit of a tricky one. So a fence is to be built around the outside of a rectangular paddock, and an internal fence is also to be built. So that's what we can see here. The side lengths of the paddock are x meters and y meters, as shown in the diagram. So a total of 900 meters of fencing is to be used. Therefore, 3x plus 2y equals 900. So the area, A, in square meters of the rectangular paddock is given by A equals 450x minus 1.5x squared. So the graph of this equation is shown below. And so here we are. So there's our lovely parabola shape that we would expect from seeing any sort of polynomial with a leading power of an x squared. So question A asks us, if the area of the paddock is 30,000 meters squared, what is the largest possible value of x? So we can use our graph here and we go and find the 30,000. So that's going to be on this line here. And so we see our first point is going to be right above 100. But there is another point, as it is a parabola, it is going to be symmetric, so more than likely to have 2 points that coincide. And we find that there's another value of x, which is 200. So the largest possible value of x for us to have an area of 30,000 meters squared is going to be x equals 200. Maybe we'll say meters there as well. So part B, find the values of x and y so that the area of the paddock is as large as possible. Okay, so this, as I've mentioned earlier, as it's a parabola, we know that there's going to be an axis of symmetry right in the center of this parabola. So we know that there's going to be 2 points with the exact same y values, right? And they're at 100 and 200. So the midpoint of those is naturally going to be 150. And that's exactly what we find to be the maximum on this parabola. So we know that x is going to be 150, right? Because we want to try and maximize the area. So we want the very, very tippity top of this parabola. So if x equals 150, what is y going to be equal to? Well, to figure out y, we actually need to return to our equation at the top of the page here. So 3x plus 2y equals 900. So if x equals 150, then 3 times x, or 3 times 150, is now going to be 450. plus 2y equals 900. And now subtracting 450, we find that 2y equals, again, 450. And now divide by 2, and we find that y is equal to 225. So we'll go ahead and write that in next to our answer down the bottom. So x equals 150, y equals 225, and again, meters. All right, part C. So using your values from part B, find the largest possible area of the paddock. So we know that the area is given by this formula here. So all we need to do now is substitute our value of x equals 150 into that area formula there. So let's see what we get then. So a equals 450 times by x, and anytime we make a substitution like this, let's just make sure we put our variable in brackets, minus 1.5 times by 150, and again, brackets squared. Okay, so when we put this into our calculator and work this one out, we get an area of 33,750 meters squared. And that's our answer for part C. Okay, on to question 20. So, lovely tax table problem here. So the table shows the income tax rates for the 2019-2020 financial year. So for the 2019-2020 financial year, Wally had a taxable income of $122,680. During this year, he paid $3,000 per month in pay-as-you-go tax. So we need to calculate Wally's tax refund, and we're ignoring the Medicare levy. Okay, so first of all, let's figure out how much tax he should be paying. So with an income of $122,680, he falls clearly in this tax bracket down here. So going through and calculating this as we normally would for any sort of problem like this, well, we say the tax payable is going to be $20,797, just this amount here, plus 37 cents for each dollar over 90,000. So the way that we write that out is in dollars. So 37 cents is 0.37. And then we're going to say the difference between how much he earned and that value there. So 122,680 subtract 90,000. Okay, fantastic. So when we calculate that, we get a value of $32,888.60. And now let's see how much tax did he actually pay. So $3,000 every month. So it's going to be 3,000 times by 12, which is going to give us a total tax paid of 36,000. So clearly now he has paid more than he should be paying. So what we need to do is we need to subtract the difference, and that will give us the total tax refund. So 36,000 minus $32,888.60. I'll write this out a little bit neater. There we are. And what we get is that he will get a tax refund of $3,111.40. And there we go. So that's question 20. All right, question 21. The inflation rate over the year from January 2019 to January 2020 was 2%. So the cost of a school jumper in January 2020 was $122. So we need to calculate the cost of the jumper in January 2019, assuming that the only change in the cost of the jumper was due to inflation. Okay, so for any style of question, it's very, very similar to like a GST style of question, right? So normally the sort of formula for that, I should say, is the initial value, normally given by P, times by 1 plus whatever the rate is. So for GST, it would be 10%, but here inflation is only going to be 2%. And that's going to be equal to our final value. So here we know that R is 2%, and we also know that F, the final price, is 122. So we just need to work this out to rearrange it for P, the initial value, or how much it cost at 2019 January. So solving that now, we get P equals the final value, 122, over 1 plus, so 2%, so I'll write that as a decimal, 0.02. And that's our answer there. So when we actually calculate that, we get just a value of P equals $119.61. And that's our answer to question 21. All right, question 22. So NISA has a credit card on which interest at 17% per annum, compounded daily, is charged on the account owing. So 17% per annum, compounded daily, okay? Emphasis on the compounded daily section. So at the beginning of the month, NISA owes $500 on her credit card. She makes no other purchases using the credit card, but 15 days later, she repays $250. So assuming that interest is charged for the 15 days, we need to calculate the amount owing on the credit card immediately after the $250 payment is made. Okay, so a couple steps to this problem here. First step is to use our compound interest formula to figure out how much she owed after 15 days. So our compound interest formula is A equals P outside of 1 plus R over N. So N is the number of periods that we have compounding, all to the power of NT. So N, again, number of periods compounding, and T is the number of years. All right, so let's go through the question and fill out these values. So the final value after 15 days is, so P is 500. We have 1 plus, so the rate is 17%, or 0.17 in decimal form. N, the number of periods per year. So it's compounding daily, so how many days are in a year? 365. And then we have it to the power of N, so again, 365. And now how many years go past? Well, there's 15 days out of 365 days. So we'll write that as 15 over 365. And you can probably notice here that in the index here, our 365s will simply cancel out, and we can just rewrite that to the power of 15. Okay, so doing that, we get a value of $503.50. And we need to now calculate, well, how much will be left after she's paid off $250. So we will subtract $250. And we find that the amount owed is now going to be equal to $253.50. And there we are. Okay, question 23. So, in a tropical drink, the ratio of pineapple juice to mango juice to orange juice is 15 to 9 to 4. All right, so before even continuing with this question, I want to kind of add those up and see what we're going to be working out of as a total. So 15 plus 9 is 24, plus 4 is 28. So we know that this will all add up to be 28 parts, essentially. So how much orange juice is needed if the tropical drink is to contain 3 liters of pineapple juice? All right, so I'm going to write this out a little bit simpler. So we have P to M to O, so pineapple to mango to orange. All right, and we know it's in the ratio of 15 to 9 to 4. So again, I'm going to write that out underneath this. And then lastly, we know that the new tropical drink that we'll be making up has 3 liters of pineapple juice. Okay, so that means now we have a ratio of 3 to something, again, to something. We don't know these numbers here, and that's what we want to figure out. So we want to figure out the orange juice. So what we do there is we want to figure out by what factor has this number changed. So we've gone from 15 to 3. So clearly, all we've done is we've divided that by 5. So if we do the exact same thing to our 4 over here, well, we get 4 divided by 5 is 0.8. And again, this is just figuring out what is the factor that we have scaled this drink by. So we've gone from 15 liters now to 3 liters. So we've reduced it by a factor of 5. So similarly for the 4 liters, now we've reduced it by a factor of 5, we get 0.8 liters. Okay, and that's actually going to be our answer there for part A, but we'll write that out a little bit nicer. So we'll say we need 0.8 liters of OJ. All right, part B. The internal dimensions of a drink container in the shape of a rectangular prism are shown. So to completely fill the container with the tropical drink, how many liters of mango juice are required? All right, so first of all, what we need to do is figure out the volume of this container. So for me, what I prefer to do is write these down in meters, just to keep things in SI units. So then the total volume of this container is going to be 0.4, so that's the 40 centimeters or 0.4 meters, times by 0.2 meters for the 20 centimeters, and again times by 0.35. And so multiplying all of those together, we get 0.028 meters cubed. And now the reason that I write this all in meters is because I know that there's 1,000 liters in 1 meter cubed. So to now convert this from meters cubed into liters, all I'm going to do is times by 1,000. And so all that does is it moves that decimal point across 3 times. And so we get that this container will hold 28 liters of the juice. Okay, so now it asks us how many liters of the mango juice are required. So if we have 28 liters, that will fit in this container. And, oh, hang on, that looks pretty familiar to something that we saw earlier. So this is in fact the exact same total amount that we'll be dividing the drink into. So that means essentially now that out of this 28 liters of space, we divide it by 28 and then we times it by the ratio of mango that we have in here. So now it's 28 over 28, or 1, times by 9. And that's it. So that number there, that's our answer. So we'll just say we need 9 liters of mango juice. And there we are. So that's question 23. Okay, question 24. So there are 2 tanks on a property, tank A and tank B. Initially, tank A holds 1,000 liters of water and tank B is empty. So tank A begins to lose water at a constant rate of 20 liters per minute. So the volume of water in tank A is modeled by V equals 1,000 minus 20T, where V is the volume in liters and T is the time in minutes from when the tank begins to lose water. On the grid below, draw the graph of this model and label it as tank A. Okay, so for this function here, so V equals 1,000 minus 20T, what we should do is simply just find the 2 intercepts. So when T equals 0, well, we find that the volume is 1,000. So we'll go ahead and mark that point in there. And then let's find our x-intercept. So what value of x would give us a 0 value for our y, or I should say, what value of t will give us 0 for our v? And we find that we get a 50-minute value for time t. So 50 times 20 is going to be 1,000. So 1,000 minus 1,000 gives us 0. Okay, so now if we try and draw this in as straight as we can, and that has already gone very dodgily, but that's not too bad there. Then that's going to be our tank A function. And there we are. So that's our tank A graph. Now, part B says tank B remains empty until T equals 15, when water is added to it at a constant rate of 30 liters per minute. So by drawing a line on the grid on the previous page, so on that graph, or otherwise, find the value of T when the 2 tanks contain the same volume of water. Okay, so we can work this out using simultaneous equations, but I think if we have a graph, let's use the graph. So we know that it's empty until T equals 15, so that means that the volume is 0 all the way up until the 15th minute there. Then after that point, we increase it by 30 liters per minute. So what I'd recommend doing here is to just find another point that we can easily graph. So let's say, what happens 10 minutes after the 15th minute? So that would be on the 25th minute. How many liters have we gained? So it's going to be 30 liters times by 10. So that would give us a point over here. So on the 25th minute, this tank has gained 300 liters. All right, so what we can do now is we can actually just simply connect those 2 points. And then if we continue extending that through the rest of the graph, well, we will find an intersection point. It is a little bit off, just owing to the fact that I haven't used a ruler, but hopefully in exam conditions, you'll make the most of your materials and you should actually use a ruler. And the intercept here, we should find that t equals 29. And there we go. So as I said, you can use simultaneous equations to do that. You could use the volume of tank A as V equals 1,000 minus 20T. And then for tank B, you do need to do a little bit of, I suppose, a little bit of more digging into it. So it's going to have a y-intercept of minus 450. plus 30t. And then you can solve those two equations simultaneously because v equals v. So you could set the right-hand side of equation 1 to equal to the right-hand side of equation 2. So we get 1000 minus 20t equals minus 450 plus 30t. So we would add the 450 to both sides and add 20t to both sides, and then we get 1450 equals 50t, and divide both sides by 50, and we can see t equals 29. Okay, don't know what happened there. So we find that t equals 29 is pretty much where we had highlighted that mark there. Okay, part C. So using the graphs drawn or otherwise, find the values of t, where t is greater than 0, when the total volume of water in the tanks is 1000 liters. Okay, so this one is a little bit trickier, and I would honestly recommend doing this one algebraically as opposed to with the graph. So let's think about what's going on here. So the two volumes, well, we'll have volume of tank A is given by 1000 minus 20t, and the volume of tank B was given by minus 450 plus 30t. So what we're saying now is that when we add those two together, we'll find that it's going to be equal to 1000 liters. Okay, so 1000 minus 20t plus minus 450 plus 30t. So what we end up with now is that 550 plus 10t is going to be equal to 1000. So we can subtract 550 from both sides, and then we get 10t equals 450. Divide both sides by 10, and we find that t equals 45. So on the 45th minute, where this would be around 100, and I think this should be around 900. And so then we'd add those two together, and clearly that would give us the 1000 liters. So we'll say t equals 45. Okay, question 25. A composite solid consists of a triangular prism which sits exactly on top of a cube as shown. So we just need to find the surface area of this composite solid. So first of all, let's look at the different sides of this cube, and that'll probably be the easiest place for us to start. So we've got 1, 2, there's one on the bottom, one on the left-hand side, and one on the back. So we've got 5 different sides of this cube that are being shown that we can actually see the surface area of. So that means that we'll have 5 times by, what's the area of one of these squares? 8 times 8. And so computing that, we get a value of 320, and this is going to be in centimeters squared. All right, so we've done all the different sides of this cube. Now let's look at the 2 different rectangular sections on this triangle. So this side here, and then on the other side there where we can't quite see. So we have 2 of that same shape. And what's the area of that rectangle there? So it has a width of 5 and it has a length of 8. So 2 times 5 times by 8. Okay, and that gives us 80 centimeters squared. And now all that's left for us to figure out is the front face and the back face of this triangle section. So this part here, and then the one on the back. Okay, so the height of this triangle, let's see what that is. So we know that the total height is 11. All the way from there to there, but we know that the height of the square is 8. So that means that this triangle has a height of 3. So let's start with that. So we know that we've got 2 triangles, front and back, and we know that the area of a triangle is normally given by a half times the height, which we just said was 3, times by the base. So what's the base of this triangle? It's simply 8. And there we go. So that will give us a value of 24 centimeters squared. So adding those all together, we find that the total surface area, so I'll write SA for surface area, is equal to 424 centimeters squared. Okay, and that is question 25. Okay, on to question 26. So question 26, worth 5 marks. The preparation of a meal requires the completion of all 10 activities A to J. The network diagram shows the activities and their completion times in minutes. Alright, so let's have a quick look at the questions that is asked here. So it says, what is the minimum time needed to prepare the meal? List the activities which make up the critical path for this network. And then down below, we'll need to look at the earliest start times and the float times for a couple different sections here. So for a problem like this, what I think is going to be our best bet on our approach of it is going to simply be to write down our earliest starting times and our latest starting times and just kind of working our way through the entire problem so that way we can see all the information really clear. So a good way of setting it out, if you don't have too much space on the actual network diagram, is to just kind of write it off to the side where you can clearly put in these boxes and you can see exactly what's going on, and I just really would recommend it. It does help quite a bit, I believe, in terms of getting all the information that you need and writing it succinctly. Okay, so let's start off. So for A, well, what would the earliest start time of that be? Well, that would clearly just be 0. For B and for C as well, we'll have the earliest start time as 0. So pretty easy so far. So that's A, B, and C all sorted. So now we would start looking ahead and start looking at D. So in order for us to start D, well, we need to have completed both B and C. So the earliest that can happen is at 8 minutes. So we'll go ahead and put 8 in there as well. Now E relies on D being completed. So that would take 8 plus the 12 minutes to complete task D, so 20 minutes. Task F requires both A and E to have been completed. So E takes 6 minutes, so that means that F must start earliest at the 26th minute. Okay, now we can start looking over at G. So we know that G only relies on D being completed. And so again, that will have a similar earlier start time of 20. Okay, so now looking at H, I, and J. So let's look at H first. So after F has been completed, so reminder, F could be started on the 26th minute. It will take 10 minutes. So that means by the time we get to this vertex here, we're at the 36th minute. So that means for both J and H, our earliest start times will be 36. Okay, and now we start looking at I. So for us to get to this base here, we must have completed F, H, and so for H, earliest it could start was at 36, plus the 8 that it takes to finish. That gets us to 44 at this vertex here. So now 44 plus 2, and that will tell us the finish time, but the earliest start time for I is simply 44. Okay, so what is the minimum time needed to prepare the meal? Let's have a quick look at both J and I and see how long it would take to actually get to this finish point. So for us to get to J, well, we know that we can start at the 36th minute. We add 7, so that means we would get to here by the 43rd minute. But if we go through I, then we can start that earliest at the 44th minute and go plus 2 for the actual task of I. So that means 46 over here. So what is the minimum time needed to prepare the meal? We would say 46 minutes. And there we go. So that's part A. So part B, it says list the activities which make up the critical path for this network. Okay, so what I'd recommend doing here is going through it and completing your backward scanning. It doesn't really matter where you want to start with it if you're comfortable with this procedure. But I'll go ahead and get us started. So if we were looking at, let's say, J, for example, well, we know that there's a difference of 3 between the 46th minute and the 43rd minute that we can get to the finish point here. So that means we could actually delay J by 3 minutes. So that means we could start it on the 39th minute. Okay, so following similar procedures for the rest, we'll find that I, we can't delay. So that would actually be 44. H, similarly, we can't delay, so 36. G, we definitely can delay G because it takes us a lot longer to go all the way through E, F, H, all the way around, as opposed to just going through G. Now, how much can we delay that by? Well, all we do is we look at the difference between these two different paths here, and we find that we can actually delay G by 15 minutes. So we'll put in 35 over here. Part F. So 26, and we see that we shouldn't delay that either, so 26. Again, for E, we shouldn't delay that, so that's going to be 20. The latest start time will be 20. Okay, and now for D, again, going to be 8. And now for C, we can't delay this any further. And B, now we definitely can delay B. So we see what's the difference between the path B and path C? Well, it's only at 2, and that's the latest start time for B. Now, for the latest starting time of vertex A, what we need to do is we need to, again, figure out how long will it take us to go from here to here, as opposed to just going through A. And so we find that the difference is going to be 12 minutes. So now, if we start looking for the activities that make up the critical path of this network, all we need to do is we need to go through and look at the different vertices and the different paths that have the same earliest starting time and the same latest starting time. So clearly that's going to be C. Then next along we have D. Then next along we have E and F. G, nope. H, yes. I, yes. So our critical path for this network is C, D, E, F, H, and I. So if it's in the critical path, that just means that you can't delay it. All right, part C. Complete the table below, showing the earliest start time and float time for activities A and G. Okay, so the earliest start time for A is 0, as we established right at the start. The float time is the difference between the EST and the LST, so essentially just 12 minus 0 here. So that's just going to be 12. And now for G, well, we just look back at what we've got up here, and yep, G earliest start time is 20, and the float time would be 35 minus 20, so that just gives us 15 minutes for the float time. And that's question 26. These questions typically do take a little bit longer than your other questions. However, it's still within the realm of 90 seconds per mark. All right, question 27. So the shaded region on the diagram represents a garden. The scale is 1 centimeter equals 5 meters. So it says, use 2 applications of the trapezoidal rule to calculate the approximate area of the garden. Should the answer to part A be more than, equal to, or less than the actual area of the garden, referring to the diagram above? Briefly explain your answer. Okay, so first thing that I would suggest that we do is actually convert from centimeters to meters. So each square is 1 centimeter, so we would say that this length here, up to that node there, is going to be 5 meters, times by how many blocks we have? 1, 2, 3, 4, 5. So that's going to be 25 meters. Okay, and so you can probably see for these 2 points over here, that's just going to be 20 meters. And now we need to work out what's the horizontal distance between these points. Well, it's 1, 2, 3, 4 blocks apart. And that's again going to represent 20 meters. From there to there, and also from there to there. I'll write that in again. Okay, so now using 2 applications of the trapezoidal rule. Alright, so our trapezoidal rule is A equals H on 2 times by A plus B. So the height here is actually the horizontal distance. So that's going to give us 20 over 2, and then A plus B are the 2 different vertical lengths. So we have 25 plus 20, and then for the other section, and so that would be for this area here. And now for the other half, we would have, again, 20 over 2, this time 20 plus 20 on the inside. And that actually just gives us this rectangular section here. Or square section even, I should say. Okay, so adding that up and actually working what that becomes, it's 850 meters squared. So quite a large garden. And that's going to be our answer to part A. So we'd say A equals 850 meters squared. All right, part B. Should the answer to part A be more than, equal to, or less than the actual area of the garden? Well, what we can clearly see from the diagram and our little drawings on this diagram is we'd say that this is going to be more than the actual area. And now if you wanted to justify this, you would probably write out what I'm just about to say. You would say something along the lines as such, that the trapezoidal rule makes the approximation on the diagram that we are taking additional areas. Honestly, that's fine. You can just leave it at that, and you'll still get the full marks. All the question wants you to do to get 2 marks for this is to say more than, equal to, or less than. That's 1 mark there. And then just giving a reason why, and just saying that this trapezoidal rule estimates the area incorrectly, and that's fine. Okay, fantastic. So, question 28. Consider the following data set. 1, 5, 9, 10, and 15. Suppose a new value x is added to this data set, giving the following. It is known that x is greater than 15. It is also known that the difference between the means of the 2 data sets is equal to 10 times the difference between the medians of the 2 data sets. So can we calculate the value of x? Okay, so let's just look at the data set 1. I'm just going to write up the top. So data set 1. So we know that for data set 1, well, let's calculate the median and the mean. So the median, I'll just write that as med, is going to be equal to 9, right? So our middle score. Now our mean is going to be given by 1 plus 5 plus 9 plus 10 plus 15, and then divide that by 5. And so when we do that, we get that that's going to be equal to 8. Okay, so now for set 2, let's see what we can determine here. Again, median, we can determine that pretty quickly. So that's going to be the middle score, or here represented as 9.5. Now, the mean we can't determine yet, but that will be our clue as to how to get x. So it is known that x is greater than 15. It is also known that the difference between the means of the 2 data sets is equal to 10 times the difference between the medians of the 2 data sets. Okay, so what that means is that, well, I'm going to call mean for the second data set. Let's call that perhaps theta, just to give it a variable. So what that means now is that theta minus mu from data set 1, or in other words, 8, is equal to 10 times the difference between the medians of the 2 data sets. So it's equal to 10 times 9.5 minus 9. And so we can work this out pretty easily, as theta equals to, so 9.5 minus 9 is 0.5, times by 10 is 5. Then we'll add that 8 across to the other side, so it becomes 5 plus 8. So theta equals 13. So that's the average of the data set from our new data set with x being added. Okay, so what we want to do now is we want to look at how can we determine this average here. Well, let's have a look at what's going on. So, well, we know that we have 40 plus x all over 6 is equal to theta. Okay, so that's just going from 1 plus 5 plus 9 plus 10 plus 15 equals 40. And then we add the x on, and then we know that if we divide it by 6, that's also equal to theta. And so substituting in that value of theta for 13, we can then solve and rearrange for x. So then we multiply both sides by 6, and then we'll subtract both sides by 40. And what we find is that x has a value of 38. And that's our problem 28, all done. Okay, now on to question 29. So Jana owns a share portfolio, and details of her share portfolio at the 30th of June 2020 are given in the table. So Jana receives a total annual dividend of $149.52 from her share portfolio. So calculate the number of shares Jana has in company XYZ on the 30th of June 2020. So we just need to figure out this section here. Okay, so to do that, we know that the total dividends add up to 149.52. And so now what we should do is figure out the dividends from each individual stock. So for company ABC, let's figure that out. So the way that we do that is simply by saying, all right, 200 times by, and so to figure out the amount that the dividend gives us, is it's going to be the dividend yield times by the market price per share, and then we times that by the number of shares that we have. So actually all we do here is just multiply this row across. So it becomes 200 times by 6% times by $5.50. And so what we find that that is equal to is just simply $66. Okay, so we now know that she earns $66 from company ABC. So how much does that mean that she's earned from company XYZ? Well, it's now just going to be 149.52 minus 66. And that leaves us with $83.52 that she's earned from company XYZ. Okay, so again, looking at our equation and how we figured that out, so that means that 83.52 is equal to, let's just put x as a variable here. So that's going to be equal to x times by 4% times by $6. Okay, and so now if we divide both sides of this equation by 4% and $6, well, we'll find 6 times 0.04, and that will give us x. And we find that x, the number of shares that she owns in XYZ, is equal to 348. And there we go. Okay, on to question 30. So the network diagram shows a series of water channels and ponds in a garden. The vertices A, B, C, D, and E and F represent 6 ponds. The edges represent the water channels which connect the ponds. The numbers on the edges indicate the maximum capacity of the channels. Okay, so we can have a little bit of a look here. So determine the maximum flow of the network. Alright, so there's one feature that we should know about networks is that maximum flow equals minimum cut. So what that means is you must draw a line from the top somehow through down to the bottom. And you should never cross 2 lines the same way. So you should never do something like that. And you should also never do something like this. Because what's going on here is now you're looking at the output of B and the input of B, which is going to make it a bit of an incorrect cut. Okay, so what we should do is it should look something maybe like this, and that's fine. So that gives us a cut of 350, but that's not going to be the minimum. So we can also do this cut over here, 150 plus 200. That's not going to be our minimum, but let's keep going. What about over here? Again, 300 plus 50, 350. Maybe let's try going through the middle, something like this perhaps. So then we'll have 50 plus 75, so 125, plus 100, so 225, plus 50, so that's 275. And that actually becomes our minimal cut. And there we are. So that's our minimal cut there, and that's the maximum flow of the network. And just leaving this working out is 100% okay. So they can see the cut that you've made, and then they can see that you've just clearly identified the maximum flow from that. All right, part B. So a cut is added to the network as shown. So is the cut shown a minimum cut? Give a reason to your answer. No. No, it isn't. So you can give 2 reasons. One, that it crosses both the input and output of B. But also the fact that when we add all that up, let's see what that equals to. So it's 50 plus 50, so 100 plus 200, 300 plus 75. So that's 375. So it's actually 100 greater than the maximum flow or the minimum cut that we've shown in part A. So you can simply just say no, since 375 is greater than 275. And that's it. That's question 30. Okay. Question 31, lovely bit of trigonometry here. So Mr. Ali, Miss Brown, and a group of students were camping at the site located at P. Mr. Ali walked with some students on a bearing of 35 degrees for 7 kilometers to location A. Miss Brown, with the rest of her students, walked on a bearing of 100 degrees for 9 kilometers to location B. So it asks us to show that the angle APB is 65 degrees. So let's quickly have a look at where that sits. So A to P to B. So we're looking at this angle here. Okay, so since we're looking at bearings, well, we know that that measures the angle from the north line to the line that joins the origin to that point. So that means that when, for Mr. Ali, that this angle here between the north and that line that joins the origin P and where Mr. Ali is at now, we know that that is 35, and we know, therefore, as well, that this line going from the north all the way round to join to the line from PB is going to be 100 degrees. And so what that means is that this angle here is going to be 100 degrees, subtract that 35 degrees. And so we'll write that out simply as 100 minus 35 equals 65. And you can add degrees onto all of those. And there we are. Okay, now it asks us to find the distance AB. So I might just quickly draw up this triangle just to help explore this a little bit better. All right, so we have 7, 9, and we know that this angle is 65 degrees. Okay, so we have two side lengths and the internal angle. So what we can use here is our cosine rule. So our cosine rule is c squared equals a squared plus b squared minus 2ab cos of c. And let's not forget, when we do substitute all these values in, that at the end we will need to square root the answer to get c by itself. Okay, so what will this look like now? So that will look like c equals the square root of, let's say a is 7, so we'd have 7 squared, plus b would be 9, so 9 squared, minus 2 times a times b, times by cos of c. So c is that internal angle there, so 65 degrees. Alright, and so when we substitute all those values into our calculator, the answer that we get is that AB is around, we'll round it to 2 decimals, so 8.76 kilometers. Okay, fantastic. So what we need to do now is find the bearing of Mr. Brown's group from, of Mrs. Brown's group from Mr. Ali's group. So give your answer correct to the nearest degree. So if I'm going to draw that ahead on the original diagram, what that would look like is something like this. So those are just our north parallels, and what we need to do here is figure out this angle theta. Make that a little bit neater, theta. Okay, so in order for us to actually determine what this value of theta will become, we need to start looking at the other angles represented. So I'm actually going to continue and draw this up on my earlier diagram, just to kind of help us get a little bit of a bigger picture. Okay, so what else do we know? We don't actually need this side length here. We know that this angle is 35 degrees. So if that's 35 degrees, well then we can figure out this angle here, as they are co-interior angles. And so if we know our properties of the transverse line going through parallel lines, we see that this is going to be 145 degrees. Alright, so we know that's 145. We know the side lengths of this one, and this side, so we actually know all the side lengths. So if I wanted to figure out this angle theta, the best option for me would actually be to figure out this angle inside the triangle and then subtract that and the 145 from 360 for us to figure out theta. So let's do that now. So I'm going to erase our cosine rule from earlier. And what we'll need to do is we'll actually need to use the sine rule here. So what we can say is that the sine of A, just referring back to our original diagram, so that's point A, so sine of angle A over 9 kilometers is actually going to be equal to sine of 65 over the opposite side length, which was 8.76. Okay, so now solving for angle A, which is this part here, we find that A is going to be equal to sine inverse of 9 times sine 65, all divided by 8.76. Okay, or in other words, A is approximately equal to 69 degrees. Okay, so now to figure out our angle theta, all we need to do is think, well, what's 360 minus 145 minus 69, and again, all of these are in degrees. So when we put that into a calculator, we find that theta, the bearing of Mrs. Brown's group from Mr. Ali's group is now going to be equal to 146 degrees. And there we go. So that's our solution to question 31. Again, a little bit of a lengthier problem, but it is a 5 marker, so you should allow some additional time for that. Okay, question 32. Let's have a look at this one. This is a very tricky problem in the HSC. Not many people actually got this one correct I recall at the time this actually made it to the news for how few students got this answer correct. So, question 32. The diagram shows a regular decagon, so a 10-sided shape with all sides equal and all interior angles equal. So the decagon has center 0. So the perimeter of the shape is 80 centimeters. Okay, so we know that if we add up all the different side lengths, the 10 different side lengths, we get 80. Fantastic. So by considering triangle OAB, calculate the area of the 10-sided shape and give your answer in square centimeters correct to 1 decimal place. Alright, so for something like this, what we should do is first off establish what is the length AB. And so we know it's 10 sides, and we know that if we add them all up together, then we get 80 centimeters. Fantastic. So we can go ahead and draw out that triangle with that information in there as such. So we know it's an isosceles triangle, so those two sides are the same length, these two angles are the same size, and we're going to have some unknown angle in here as well. Alright, so let's see what we know about regular sided shapes. So we do actually know a formula to figure out the total internal angle of regular shapes. So the total internal angle, so when you add up all the internal angles, that's actually given by this formula. So n minus 2 in brackets times by 180. So you probably have learned this, I'd say year 9 or year 10, and then you never cover it again in years 11 and year 12. So that's why a lot of students actually found this question to be a little bit difficult. They kind of knew what they were meant to do, but it had just been too many years since they've actually used this information for many of them to figure out what to do. And so what we get is that n is the number of sides, so 10 for a regular decagon, so then we just end up with 8 times 80. And so that gives us 1,440. And so what we need to do now is we need to figure out, well, what is the size of each individual angle? So, for example, here to here, here to here, here to here, so on and so forth. So what we do is we divide that by 10, and that tells us the different angles at each individual point. So that's pretty easy to do, so all I'm going to do is just change that up there. Good. So we have 144 degrees at each corner. But now let's see what's going on with this triangle. So this triangle is actually cutting this angle in half. So when it joins from the origin to point A, and from the origin to point B, it's actually cutting it in half. So we will have each of these angles is going to be equal to half of 144, or 72 degrees. And so that means now that we can determine this angle in here as well as 36 degrees. Okay, so what we can do now is we can use the sine rule once again to figure out our unknown lengths on the side. Let's call that r for the radial distance. Okay, so let's do that now. So that would become r over sine 72, going to be equal to 8 over sine 36. Alright, so r just becomes equal to 8 times sine 72 divided by sine 36. So r is just equal to about, let's say like 12.944 or something like that. Okay, so now we need to figure out the area of this triangle, and now we can finally do that. So the area of a triangle, remember, is given by the formula half AB sine C. And so what I would recommend that we can do here is use the two different side lengths of R, and we'll use C as the internal angle there. So now we would say half times A, which is R, so 12.944, times by B, which again is 12.944, so we can just square that, and now times by sine of 36. And that gives us the area for one triangle, but what we want to do is we want to figure it out for the entire decagon. So all we need to do now is times that by 10, and then we'll have our final answer. So the total area is now going to be equal to 492.4 centimeters squared. And there we are. So that's question 32. So as I said, not many people actually got that answer correct. I think it was one of the highest rates of unsolvability, shall we say, in recent years of the HSC. Okay, question 33. The graph shows the number of bacteria y at time n minutes. Initially, when n equals 0, the number of bacteria is 1,000. So find the number of bacteria at 40 minutes. Okay, well, all we need to do here is, first of all, let's take a quick look at our graph. So when n is 40, well, we can see that we have 4,000 bacteria. Cool. That's our answer. So pretty straightforward there. So now for part B. The number of bacteria can be modeled by the equation y equals a times b to the n, where a and b are constants. So it says, use the guess and check method to find to 2 decimal places an upper and lower estimate for the value of b. The upper and lower estimates must differ by 0.01. So that's all good and well, but I think what we can actually do is we can solve this relatively easily, I might add. So let's look at our formula. So y equals a times b to the n. Alright, so y is going to be the number of bacteria, and n is the number of minutes. So let's use that point that we were just looking at. So when y equals 4,000 and n equals 40. So what happens then is we have 4,000 equals a, which we'll leave blank for a little bit, times by b to the power of 40. Okay, so what is a? So a is our y-intercept. So a is actually just going to be 1,000. So we can put that in there now. So 4,000 equals 1,000 times by b to the power of 40. Okay, so rearranging that, we find that b to the power of 40 is equal to 4,000 over 1,000. We can just write that as 4. So now for us to get b by itself, what we can do is we can actually just take the 40th root of 4. So what that looks like is this. And the answer that we get from that is actually equal to 1.04. And that's your answer there. So if you have gone through and shown this sort of working out, then you will get full marks. But if you'd kind of just leave it, at this point here, you probably won't get full marks. The reason for that is because they want to see it to 2 decimal places. They have also asked for an upper and lower estimate value for b. So if you really wanted to, you could say that the answer is going to be between 1.03 and 1.04. Although if you have done all of this, you will get full marks for this question. Okay, question 34. So Tina inherits $60,000 and invests it in an account earning interest at a rate of 0.5% per month. So each month, immediately after the interest has been paid, Tina withdraws $800. So the amount in the account immediately after the nth withdrawal can be determined using the recurrence relation. So we have a sub n equals a sub n minus 1 times by 1.005 minus 800. So n is going to be an integer value, and we know that a naught equals 60,000. So use the recurrence relation to find the amount of money in the account immediately after the third withdrawal. So that means we're looking for a sub 3. Okay, so that's our goal. So we know that a sub 3 is going to be equal to a sub 2 times by 1.005 minus 800. And now we just need to figure out a sub 2. So a sub 2 is equal to a sub 1, again, times by 1.005 minus 800. Now we need to figure out a sub 1. So a sub 1 is equal to a sub 0, which thankfully we do know, times by 1.005 minus 800. Okay, so now if we go back through and we start working all these numbers out, well, we find that a sub 1 is going to be equal to 59,500, and that's just from using the fact that a sub 0 is 60,000. Okay, so we go back, sub in that information, and this is what we'll get. We also get that a sub 2 is going to be equal to $58,997.50. And then we get that a sub 3 is equal to 59,000, oops, sorry, my mistake, is equal to $58,492.49. And that's your answer there. So we'll write that out a little bit neater. So we'll say a sub 3 equals $58,492.49. And that's our answer for part A. So for part B, it asks us to calculate the amount of interest earned in the first 3 months. Okay, well, let's have a think about this logically. So we know that she's taken out $800 each month for 3 months. So how much money has she taken out? She's taken out 2,400, or 300, or 3 times 800. But let's actually see, is the difference between the initial of 60,000 and the final value amount of 58,492 and 49, is that equal to a difference of 2,400? I don't believe so. So what we can do is we can figure out what's the difference between those two numbers. So 60,000 minus $58,492.49. We get that the difference there is now going to be equal to 1,507 and 51 cents. So what that means is that she has actually earned a little bit of money in that time from the interest. So the interest is going to be equal to 2,400 minus the actual difference there of $1,507.51. Or simply put, the interest that she earned on those 3 months is $892.49. And there we are. So a little bit of a trickier mathematical financial problem here, but if you're comfortable with your recurrence relations, then you know that you can just kind of work through it. It's just very much a plug and chug sort of problem, and then you should get through it just fine. Okay, question 35, a 7-mark question now, so quite a doozy. Alright, so the intelligence quotient, IQ, scores for adults in City A are normally distributed with a mean of 108 and a standard deviation of 10. So the IQ scores for adults in City B are normally distributed with a mean of 112 and a standard deviation of 16. So Yin is an adult who lives in City A and has an IQ of 128. So what percentage of the adults in this city have an IQ score higher than Yin's? Okay, so let's look at City A. Alright, so City A has a mean of 108 and a standard deviation of 10. So what we should do is we should figure out Yin's Z-score. So Z-score formula is x minus mu all over sigma. So that means that we'll find that it's going to be 128 minus mu, the mean of 108, all divided by sigma, standard deviation of 10. And so what we find is that we'll have 20 on top divided by 10, so Z is equal to 2. And so now, if we know from our empirical rule, if I try and draw up the bell curve real quick, we know that within 1 standard deviation, we'll have 68% of all of the data. Then we know that within 2 standard deviations, we'll have up to 95% of the data. So that means that within here to here, we have 95% of all the data. So that means that there's a little 2.5% over here and 2.5% over here. And so we actually see that Yin lies exactly on this line over here. And so we see that, to answer the question, what percentage of the adults in this city have an IQ score higher than Yin's? Well, it's just going to be 2.5%. And you can give a little bit of background information on that if you don't feel comfortable with just writing 2.5% as an answer. So you could say, from the empirical rule. Oops. And there you are. So that's part A. So part B. There are 1 million adults living in City B. So calculate the number of adults in City B that would be expected to have an IQ score lower than Yin's. Okay, so for City B, we now have different values for the mean and for the standard deviation. So let's have a quick look at that. So for City B, let's figure out Yin's Z-score. So it's again going to be 128 minus, what's the mean of City B? It's 112, and the standard deviation is 16. So in City B, she has a Z-score of 1. And so again, as I said in the previous section, the empirical rule is going to apply very heavily here. So calculate the number of adults in City B that would be expected to have an IQ score lower than Yin's. So we know that if we have a look at our bell curve, we have that there's 1 standard deviation. We know that this contains 68% of the data. So that means that on either side of the mean, right in the middle, we have 34% here and 34% here. Okay, so what that means for us now is that we'll have 50%, i.e. the entire left-hand side, plus 34%. And that's all going to be lower than Yin's IQ score of 128. So our final answer here is going to be 50% plus 34%. And then what we're going to do is we're going to times that by 1 million for the number of adults living in City B. And we find that the answer is 840,000. And that's our answer to part B. So part C, Simon, an adult who lives in City A, moves to City B. The Z-score corresponding to his IQ in City A is the same as the score corresponding to his IQ in City B. By first forming an equation, calculate Simon's IQ score. Give your answer correct to 1 decimal place. Okay, so what we can do here is make up 2 equations. So we know for City A that his Z-score must be equal to his actual IQ minus the mean, which was 108, all divided through by the standard deviation of 10. And then we know that for City B, his Z-score again is equal to his IQ, now minus 112, and divided through by 16. Okay, so what we can do here, since we know that the Z-score values are the exact same, we can actually just equate these 2 equations. So what that means we get x minus 108 all over 10 is now equal to x minus 112 all over 16. Okay, and so what we should do is just cross multiply, and then we'll be left with 16x minus 108 times by 16, so that is 1,728. And that's going to be equal to 10x minus 1,120. Okay, and now we just have a pretty standard algebraic problem to approach. So we'll minus 10x from both sides, and we'll maybe add 1,728 to both sides, and what we'll be left with is that 6x is equal to 608. And then last step here, dividing both sides by 6, we find that x, his IQ, is equal to 101.3. And that is correct to 1 decimal place. Okay, question 36, our second last question here. So a cricket is an insect. The male cricket produces a chirping sound. A scientist wants to explore the relationship between the temperature in degrees Celsius and the number of cricket chirps heard in a 15-second time interval. So once a day for 20 days, the scientist collects data. Based on the 20 data points, the scientist provides the information below. So we have a box plot of the temperature data, as shown there. So the mean temperature in the data set is 0.525 degrees Celsius below the median temperature in the data set. So right off the bat, before we even look at the rest of the question, let's see what that mean actually is. So we know that the median on a box plot is always that middle line there. So if the mean mu is equal to 0.525 less than 22, there we are, well then we can say that the mean is just going to be equal to 21.475 degrees Celsius. Okay, cool. So now let's continue with the rest of the question. So a total of 684 chirps were counted when collecting the 20 data points. Okay, so let's maybe find the average of the data points in terms of the chirping. So on average, how many did we detect? So the mu for the chirps is going to be 684 divided by 20. And so what that'll leave us with is actually simply just going to be 34.2. Okay, cool. Let's continue. So the scientist fits a least square regression line using the data xy, where x is the temperature in degrees Celsius and y is the number of chirps heard in a 15-second time interval. So we have this equation here, where b is the slope of the regression line. Okay, so one thing to note now is that we've assigned the degree Celsius to be the x variable and the number of chirps our y variable. So what we should probably do now is go back and redefine these as the average x and the average y, just so that way we're keeping up to date with our notation here. Okay, so the least squares regression line passes through the point xy. Fantastic. So our averages, where x average is the sample mean of the temperature data, and y average is the sample mean of the chirp data. So we've already found those two, so that's fantastic. So then it asks us, calculate the number of chirps expected in a 15-second interval when the temperature is 19 degrees Celsius, and give your answer correct to the nearest whole number. Okay, so for us to actually approach this, what we need to do is we need to figure out our constant term b. So our term here b actually corresponds to the gradient on this equation, and all we need to do now to figure that out is substitute in the other values that we have, since we know that it passes through the average point. So that means we substitute those values into this equation here, and we end up with 34.2 equals to minus 10.6063 plus b, we don't know that yet, times by x average, which is 21.475. Okay, and so if we approach this just like a standard sort of linear problem, we can rearrange and see that b is going to be equal to 34.2 plus 10.6063 divided by 21.475. So b is now going to be equal to 2.08644. All right, fantastic. So now we're ready to solve this problem. So now calculate the number of chirps expected in a 15-second interval when the temperature is 19 degrees Celsius. So give your answer correct to the nearest whole number. So y is the number of chirps, x is the degree Celsius. So all we need to do now is substitute that value in. So we end up with y equals minus 10.6063 plus b, which is 2.08644, times by x, which we're now setting equal to 19. And so when we calculate that, we just get a value of 29. And that's our solution there. So that's a little bit of a tricky problem. It was worth 5 marks, but if you approach a problem as you go through it, then right at the end you'll actually see that it's really not too difficult. So as we already had found the average x and the average y without even realizing we needed to, we've already pretty much done half the problem. Okay, so the final question now, and then we're done with the 2020 HSC paper. So question 37. Wilma deposited a lump sum into a new bank account which earns 2% per annum compound interest. So present value interest factors for an annuity of $1 for various interest rates R and a number of periods N are given in the table. So we have a table of present value interest factors. So Wilma was able to make the following withdrawals from this account. So $1,000 at the end of each year for 20 years, and $3,000 each year for 10 years, starting 21 years after the account is opened. So calculate the minimum lump sum Wilma must have deposited when she opened the new account. So this is interesting, and what I'd like to do is I'd like to think about what's happened here in terms of maybe like a little timeline. So I'm going to draw this up, more of a time bar, I suppose. So we've got 10 years, 20 years, 30 years. I'll draw that in as such. And this is the initial deposit at 0 years, let's say. So that means for the first 20 years, she has gotten $1,000 back, right? So up to this point here, we're working in terms of $1,000. And that's not too bad. But then afterwards, for the last 10 years, we're now taking out $3,000 each year. And so the reason that I try and draw this out is because we can actually figure this out pretty nicely. Well, first of all, one thing we do know is that it's 2% per annum, so we know that we're definitely going to be using this column here. So all this other stuff is just to sort of throw you off, I suppose. So now, if we wanted to figure out the first 20 years, well, we know that it would then be this row here for the 20, and so we would find that we have 16.351. Okay, so that means that for the first 20 years, she must have deposited 16.351 times by how much did she make in each withdrawal? $1,000. Okay, and that's how much she has deposited in order to get the first 20 years worth. And that's simply just going to be $16,351. Now, where it gets tricky is figuring out how did we get to this stage here from the 20th to the 30th year. So essentially what's happened is we've put in an imaginary amount that would allow us to take out $3,000 for the entire period for 30 years, and then we've just taken off the first 20 years of that. So then we're scribbling that part out, and all that's left is going to be 3,000 in the last 10 years. And that's exactly what's happened here in this problem. Okay, so now to figure out how much money would you have had to have put in for $3,000 for 30 years, well, now we're going to be using this 22.396. So we'd say 22.396 times by 3,000. Okay, and so that will give us $67,188. But as I've just mentioned, we are getting rid of those first 20 years, since we know that for the first 20 years, she only withdrew $1,000, not $3,000. So how much would it have taken to withdraw the $3,000 for the 20 years? Well, that's just going to be equal to the 16.351 times by 3,000. And we find that that's equal to $49,053. Okay, so what we need to do now is think about which section represents which years. So this first section represents years 0 through to the end of the 21st year, I suppose, or 20th year, start of 21. So this is 0 to 20, I'll just write it like that. And now to figure out what happens from 20 to 30, it's just going to be the difference between these two numbers here. So the difference between those two numbers, 67,188 minus 49,053, well, that'll simply give us $18,135, and so that will cover the years from 21 through to 30. Okay, so all we need to do now is add up the two amounts for those two different periods, so from 0 to 20 and from 21 to 30. And so we find that it's going to be a total initial deposit, so we'll write it out thoroughly. So we'll say initial deposit is going to be equal to $16,351 plus $18,135, or in other words, a total initial deposit of $34,486. And that's our final answer there. And that concludes the 2020 HSC. So look, I do hope you found this video useful, whether you have watched the entire thing or if you've just gone and looked at specific questions, both 100% okay. But if you have enjoyed it, please leave a like. Don't forget to subscribe. It does mean a lot to me. And if you do have any questions, feel free to drop them down below and I will try to get back to you as soon as I can. Appreciate it. Cheers.